Hello students, welcome to AIMS India online classes. This is a chemistry session. Here we are discussing about the chapter Combustion, Fuels and Flame. In this session we are going to see especially about fuels and flame. First let us go through fuels. Fuels are the substances that react chemically with another substances to produce heat, or the substances that produce heat by nuclear process. These are called fuels. So generally known fuels are the substances which react with generally oxygen to produce heat and light. Those are called fuels. The term fuel is generally limited to those substances that burn readily in air or oxygen, emitting large quantities of heat. In the earlier sessions we have seen the substances which react with the atmospheric oxygen and produce light and heat as combustible substances. But out of these all kinds of combustible substances, that substances which readily react with the atmospheric oxygen and produce large quantity of heat can be considered as fuels. So all the combustible substances may not be used as fuels. Out of those which are producing large quantities of heat and they burn readily with the oxygen can be used as fuel. These fuels are used for heating purpose, for the production of steam, for power generation purpose, and for powering internal combustion engines, and for a direct source for powering in jet and rocket propulsions. So in these all fuels are used even in the vehicles, for running of automobiles. These are also using these fuels. These fuels are of three types. Mainly they are classified into three types based upon the state of the physical state of the fuel. They are solid fuels, liquid fuels, and gaseous fuels. If you say about solid fuels, the common solid fuels are like coal, coke, charcoal, wood, sugarcane bagasse. Sugarcane bagasse means we know sugar is extracted, sugar juice is extracted from sugarcane, isn't it? So after the extraction of sugarcane juice, the remaining part, the waste part remained is called bagasse. That is also used as fuel for burning purpose and for domestic cooking purpose also that is being used. And the peat, it is one of the forms of coal. It is also used for production of heat. So these all come under solid fuels. Okay, next liquid fuels. The common liquid fuels are oils, gasoline, and naphthas derived from petroleum. Certain liquid fuels are which are derived from petroleum. And to a lesser extent, coal tar and alcohol. These are liquid substances which are used as fuels. Mostly for running of these automobiles and vehicles, we use the liquid fuels obtained from petroleum. We know petroleum is one of the crude product obtained from the earth crust. Under the layers of the earth, from the under the layers of the earth, it is collected and it is refined. It is purified into different fragments. So this petroleum is containing so many liquid fuels mixed in it. So those all will be separated and they are used as fuels now, like petrol, diesel, kerosene. These all are derived from this petrol or petroleum. Okay, these all will come under liquid fuels. And there are some gaseous fuels also. The common gaseous fuels are CNG. We know what is meant by CNG. Compressed natural gas. Isn't it? It mainly contains methane. It is compressed to high pressure and it is stored under cylinders and it is used as fuel at machineries and even automobiles also nowadays they are using this. And LPG, one more gaseous fuel is LPG, which is very familiar to us because it is mostly used in all the houses nowadays, isn't it? The gas cylinders which we use at homes for cooking purpose contain this LPG. LPG means liquefied petroleum gas. It also contains majorly one of the uh, organic hydrocarbon gas. It is called butane. Okay, so this is also compressed to very high pressure and stored in cylinders. So it is called LPG. And biogas produced from bio waste. Hydrogen is also one of the gaseous fuels. Refinery gases and manufactured gases such as producer gas. Nitrogen and carbon monoxide mixture is called producer gas. This is prepared in the laboratory. So these all are gaseous fuels. Okay, most familiar to us is LPG and CNG. Even hydrogen is also one of the best fuels because it produces large amount of heat energies. So in this way, fuels are classified into three types mainly based upon the physical state of the fuel which we are using. Solid fuels, liquid fuels, and gaseous fuels. Next, the calorific value of a fuel. This calorific value of a fuel is defined as the amount of heat energy produced on complete combustion of 1 kg of a fuel. Means when you burn 1 kg of a fuel completely, then the amount of heat energy liberated is known as its calorific value. It will be different for different fuels. Some fuels they release a large amount of heat energy by burning 1 kg of fuel, and some fuels they release less amount of energy only by burning of 1 kg of fuel completely. So this amount of energy which is released by burning of 1 kg of fuel by complete combustion of 1 kg of fuel is called its calorific value. As we are telling, it is energy per kg. This calorific value of a fuel is expressed in kilojoules per kg. Means the amount of energy in terms of kilojoules released per kg of the fuel. Kilojoules per kg is a unit of calorific value. As we told, hydrogen has the highest calorific value among all the fuels. So when we compare the heat energy produced from different fuels, hydrogen produces large amount of heat energy when it is burned 1 kg of hydrogen than any other gases or any other fuel. So highest calorific value is there for hydrogen gas. Okay. Now let us see the characteristics of a good fuel. What characters should it a fuel should have to be a good fuel? What are the ideal characteristics of a good fuel? Let us see here. It should be cheap and readily available. Should not be costlier, and it should be available in the easy way. Then it can be called as a good or ideal fuel. It should be easy to store. It should not take much space and should not be unsafe for storing. So it should be easy to store, and it should burn at a slow rate, and its combustion should be controllable. So it should burn at a very slow rate, and its burning should be controllable. Then we can call it as an ideal fuel. It should not be burnt at rapid rate. Then that such kind of fuel may produce explosions also. So if we should have slow combustion rate, and its fire or its burning should be controllable, then it is said to be ideal fuel. It should have low ignition temperature. What is meant by ignition temperature? We told the temperature at which the minimum temperature at which a substance catches fire is called its ignition temperature. So if it is having low ignition temperature, by heating to low temperatures only, it starts burning and it produces heat energy. Then it called ideal fuel. If it is having higher ignition temperature, more amount of heat energy will be wasted for starting burning there. So it should not have high ignition temperature. It should have low ignition temperature, and it should have high calorific value. It is the remaining points. It should produce very small amount of residues such as ash. So should not leave any polluting causing substances after completion of combustion. Should not leave any residues. Then only it is called an ideal fuel. Suppose if you burn certain wooden objects, what happens? They burn, and after completion of burning, they leave certain residues like ash, and this all will be remain. Then it is not said to be good fuel or ideal fuel. An ideal fuel should not leave any harmful and pollution causing residues after completion of combustion. It should have large calorific value. What did we say? The calorific value means the amount of heat energy liberated when 1 kg of fuel is completely burned in the presence of sufficient amount of air. So if it is producing large amount of heat energy, then it is said to be a good fuel. Okay, it should have large calorific value and low ignition temperature, and it should not produce gases which pollute the air. This is also very important, that a fuel while burning, that should not release any harmful or pollution causing gases into the atmosphere. Then only it is said to be an ideal fuel. It should be easy to store and transport, and should not produce any hazards during transportation. Okay, it should be in position to store or transport in the easy way, and it should not produce any hazards during the transport of the fuel. Then it is said to be an ideal fuel. Okay, these are the characteristics of a fuel to be an ideal. Now, advantages of using gaseous fuels over solid fuels. What are the advantages in usage of these gaseous fuels over the solid fuels? We know the calorific value of these gaseous fuels are much higher than that of solid fuels. For example, if we take hydrogen, we told hydrogen has the highest calorific value. It produces large amount of heat energy by burning it. So that is one of the advantages of using gaseous fuels over the solid or liquid fuels. And gaseous fuels do not leave any residue. Hence, there is no wastage as compared to solid fuels. This is one more important point here. Being best ideal fuels, these gaseous fuels are being ideal. That is, they do not leave any residues. They don't leave any solid or liquid residues. If you burn a solid fuel, they leave certain residues like ash, isn't it? For example, if we take wood or coal, if we burn them, after completion of burning of those, we can find the remain of residues like ash. But if we burn a gaseous fuel like hydrogen, are we observing any residue remain back? No. We see at our homes we use LPG, liquefied petroleum gas, for cooking purpose. On the stoves we see LPG will be burnt. After completion of the burning, do we observe any residue remain there on the stove? No, we don't. Because they are not leaving any residues after completion of the burning. Then that is why these gaseous fuels are preferable than that of solid fuels. It is convenient to store gaseous fuels while solid fuels occupy a lot of space. It is also one of the important reason for preferring gaseous fuels than solid fuels. Gaseous fuels can be stored in the small place. See, in our again, let us take example LPG cylinder which we use at our homes. It occupies a very small space, and the gas present in that cylinder we use nearly 1 or 2 months for cooking continuously, isn't it? Daily we use that. It comes nearly 1 or 2 months for us. For cooking the same 1 or 2 months, if we take any solid fuel like logs, wood, or coal, the fuel which we take solid fuel will occupy large space in our home, isn't it? So that is also one of the advantages of these gaseous fuels. They can be stored in the small place. It is convenient to store these gaseous fuels, whereas these solid fuels occupy a lot of space. Now let us go through the flame. Flame can be defined as the glowing body of a mixed gases undergoing the process of combustion. Flames are generally consist of a mixture of oxygen and another gas, usually such as combustible substances as hydrogen or carbon monoxide or any hydrocarbon. These are hydrocarbons are organic substances which are containing carbons and hydrogens in their molecules, which we learn in the higher classes. Okay, mostly these LPG, CNG, we say petrol, diesel, these all will come under hydrocarbons. So a flame generally consists of oxygen and any one of these hydrocarbons or hydrogen or carbon monoxide. These gases will be burnt in the presence of oxygen in the production of that flame. A typical flame is that of a burning candle. Okay, we can say a burning candle is one of the examples for a flame. When the candle is lighted, the heat of the matchstick melts the wax. See, when you start lighting a candle with the matchstick, the heat of that matchstick first melts the wax around this wick, which is carried up the wick and then vaporized by the heat produced there. So first, when you start heating this, lighten up this by using a matchstick, the wax around this wick starts melting and rises up into the wick and it vaporizes first because of that heat. These vapors of wax are then broken by the heat and finally combines with the oxygen of the surrounding air, producing a flame and generating heat and light. So this is happening before starting that flaming of the candle. What's happening when you bring a lightened matchstick near the wick of that candle? The wax around the wick first it melts up and it rises up into the wick, and there because of the heat produced from the match that wax liquefied wax first it vaporizes and it breaks down into small, broken down by the heat, and finally that combines with oxygen surrounding the surroundings air, and then it starts combustion and gives a flame with light and heat. Okay, the candle flame consists of three zones that are easily distinguished. Okay, a candle flame can be separated into three zones mainly. They are outer zone or outermost zone. So this zone is called light blue colored seen here. That is called outer zone or outermost zone. And middle zone. This yellow colored or orange colored. This comes under middle zone. And inner zone or innermost zone. Here the black colored nearby the wick it is seen here. This is called inner zone or innermost zone of a candle flame. So in this way the flame of a candle can be segregated into three parts: outermost zone, inner zone, and innermost zone, middle zone and innermost zone. Okay, in the outer zone complete combustion of the fuel takes place because this for this outermost zone sufficient amount of air is available from the surroundings. It is being in contact with the air directly, so it takes a sufficient amount of oxygen and a complete combustion of the fuel takes place there, and the color of the flame will be here blue. And as it is complete combustion of the fuel is going on, it is the hottest part of the flame. It produces large amount of heat, so we can say the outermost zone is the hottest part of the flame overall, and it there the fuel burns the blue flame, and there occurs complete combustion of the fuel because there the vapors of the fuel are coming in contact with the air directly and they take sufficient amount of oxygen, and hence complete combustion occurs. Okay, it is the non-luminous part of the flame. Okay, the outermost zone is said to be the non-luminous part of the flame. Next, if we see the middle zone of the flame, the middle zone is it occurs there the partial combustion of the fuel takes place, and the color of the flame is yellow, and it is moderately hot part of the flame because there the supply of oxygen is somewhat less compared to the outermost zone, because there itself, in the outermost zone itself, most of the air which is in the surroundings is burned to combust the fuel. So as there is a insufficient amount of oxygen supply to the middle zone part, there occurs partial combustion of the fuel. That's why the color of the flame will be yellow, and hence it is a moderately hot part of the flame. It is a luminous part of the flame. There the glow of the flame will be in yellow color. Next, the inner zone of the flame. In the inner zone, there are unburnt vapors of the fuel because there is no supply of oxygen gas to that inner zone. The gas which is surrounding there the flame is burnt in the outermost zone and middle zone itself. There is no proper supply of oxygen gas for the burning of these vapors of fuel at the middle innermost zone. That's why it is said to be unburnt vapors of are present in the innermost zone, and the color of the flame in this innermost zone is black. As it is not burning there, it is a least hot part of the flame. The innermost zone is least hot part because there unburnt vapors of fuel are present. They are not burning because of the non-supply of fuel there, non-supply of air to that. Okay, in this way, the flame of a fuel can be segregated into three different parts. Outermost zone, the hottest part of the flame, their fuel burns completely with the blue color. It is the hottest part. It is non-luminous part also. And the middle zone, there occurs partial combustion of the fuel. There the color of the flame is yellow, and it is moderately hot because in partial combustion is going on, and it is a luminous part of the flame. Whereas in the innermost zone, there are unburnt vapors of the fuel because there is no burning is happening at the middle innermost zone, as there is no supply of air to that, and hence the color of the flame will be black, and it is least hot part in the overall flame. Okay, now let us see one point. Why do goldsmiths use the outermost zone of the flame for melting gold and silver? Have you ever observed the goldsmiths? They use the outermost zone of a flame for melting gold and silver ornaments while designing them into different shapes. They use this outermost zone of the flame. Goldsmiths use the outermost zone or non-luminous part of the flame for melting or shaping gold and silver ornaments, isn't it? They direct the non-luminous part of the flame of a candle or any Bunsen burner on the gold or silver with the help of a blowpipe. See here, from the Bunsen burner, here flame is coming. The outermost zone of the flame will be the hottest part generally. So they are blowing this outermost part of this flame onto the this gold or silver ornament by using a blowing pipe. So this outermost zone, the temperature of this outermost part of the flame will be around 1300 degrees Celsius temperature. It is sufficient to melt the gold or silver at the specific point, and thus this helps the goldsmiths to give proper shape to the gold ornament. So in this way they design that into different shapes or desirable shapes that gold ornament. That is why only they use this outermost zone of the flame by using blowpipes to melt or to bend them into different shapes. Okay, that's about flame. Thank you for watching our video. Please subscribe our YouTube channel Aims Today and visit our website aimstoday.in for latest updates and recorded videos.